Good afternoon. This is the presentation I gave for datalift number 6. It's a post recording. I'm going to present now the presentation Machine Learning Forecasting for Unified Steering and Planning in E-commerce Platform. My name is Carlotta Schatten. I have a PhD in recommender systems, and I'm currently working as a team lead data scientist for Flaconi, where I'm responsible for 3 main use cases, such as recommender system, forecasting, and customer lifetime value. In order to present you the challenges of forecasting for e-commerce systems, for e-commerce, I'm gonna start from our state-of-the-art solution, where we're going to discuss how to solve the challenges that arise when trying to address planning and steering at scale for a large assortment. There are 4 sections where I'm going to address different aspects, the process, the demand forecasting problem, the machine learning modeling, and how to have efficient monitoring and alerting. For the process, one needs to think that our stakeholders, based on customer products demand and business steering, try to plan how much they're gonna sell, the company is gonna sell in T days. So you have to think that different departments like the assortment team, marketing team, and campaign team come together to design the commercial plan. The goal for these teams, for instance, are for the assortment to decide what brands to onboard, for marketing, quantify the marketing cost, for campaign, decide the discounts on our web page and how much it's gonna be. The plan can be at different levels. It can be at a category, brand, or at the most granular level, at product level. Out of this commercial plan, it is then necessary to derive the requirements of the inventory plan that contains the constraints of the warehouse and the suppliers' delivery time and the acquisition cost of these items. Of course, this needs to happen at different time steps. Companies usually select an approach of dividing the plan in strategic, tactical, and operational plans that happens at with different time steps and different periods in time. For instance, the strategic plan could happen once a year, the tactical plan each quarters, and the operational plan each month or even each weeks. After the conclusion of one operational plan time frame, the actual plan gets compared with the sales, and this information is taken into account for the second operational plan and recompared in a feedback loop to the tactical plan. The same happens at the end of the tactical time frame with a comparison with the strategic plan. Here is also important to mention that the actual sales are only a indirect representation of the demand, which is unobserved, can be considered as an unobserved variables. And here and therefore it's also important to consider that of course, by changing the business steering decision, for instance the discount, we're going to change also what are the actual sales. For this reason, if you want to support this process by machine learning, you need to consider that the developed forecast is going to be only a guideline, because we're changing important input conditions after having generated the prediction. For this reason, I usually recommend to consider the business steering upfront. For instance, as in this example, one should consider the discount marketing cost as input variable for the model and generate several prediction for each of the possible steering variable combinations, and therefore go more into the direction of operation research. So one generates a simulation of possible scenarios, and with having the prediction of the sales for the different input variables, business steering, one could either let a human decide what is the best scenario and scenario outcome, or even apply an optimization strategy on top. The examples of doing this automatically could be dynamic markdown pricing, overstock pricing. In terms of demand forecasting, I'm going to consider the most challenging use case that we have in production, which is a product's demand prediction. Here we have different challenges. One intrinsic challenge is the different demand functions that are needed to be modeled. If we consider two main dimensions for demand for products, we have items that are sold frequently with a high volumes and are quite stable in their demand. We have frequently sold high volume sold products, but highly seasonal, like sun creams. And we have also long tails that are sold seldomly or for substitution effects for missing key value items. Of course, all these demands are influenced in an unlinear fashion by covariates such as price, marketing costs, and so the dimensionalities I mentioned before, but also weather and specific seasonalities like Christmas. And and then there is also a problem of observability of demand, as I mentioned prior. For instance, the out-of-stock case. The out-of-stock case cannot result in observed zero sales, but this doesn't mean that there is a lack of demand. As such, the sales of those items cannot be taken into account in the evaluation of the model. And to some sort of sense, this applies also for zero sales. Not only, of course, this could mean a lack of demand, but there is also a high impact on the visibility of the products on the website, which might not be advertised as other ones, and generate zero sales. The same in terms of operational challenges. We are since this model is in production, we need to take into account the entire life cycle of the product. And this is particularly challenging for new products where we have no prior information. And this is comparable with the issues that are faced in a recommender system called that are called the so-called cold start problem. So for this reason, it's important to evaluate, given the assortment and what we're trying to predict, it's important to evaluate in advance all the effects that I previously mentioned, and also consider the trade-off between the model complexity and maintenance effort. The usual challenge to address these different challenges is usually to select different models in a stacking approach or increase the complexity of the model, but this of course requires higher maintenance effort and computational costs, of course, because if you generate free models, then you need to maintain also free models, monitoring, alerting, and etc. In terms of modeling, I would like to present you three approaches that we have that we worked on. We initially had a state-of-the-art model based on exponential smoothing, which is a typical time series approach. However, this approach didn't allow us to model the scenario as we wished to. We were able to reconcile to some degree specific the impact of specific covariates such as price, but not to the extent we wished to. For this reason, we changed to deep learning. We're using a pre-implemented architecture called DeepAR, available on Amazon SageMaker, AWS SageMaker. And this allows us to take into consideration covariates and model out of stock, and therefore we are able to consider generate different scenarios for each use case, that for each product that we are considering. I would like also to mention regression here, which we are not, of course, using for products demand forecasting, but if you are trying to model one time series with a lot of side information, and you're able to reconcile the time dependencies in the model selection, it was working quite well. Here I present our stack. We are running our experiment on exploiting Databricks unified infrastructure that allows us to have a simplified operationalization of our architecture in different ways. If you want to know some more details about our experience with it, I just gave an interview with them a few weeks ago. It was published, and I'm putting the link here if you're interested. In terms of processes, we have two main processes, the training and prediction. The training, it's good to have them happen separately, because the training usually is not executed together with the prediction. Retraining is not necessary with the same frequency. We have full data input and data output historization and model versioning. And at the end of prediction, also technical and key performance indicator monitoring via Tableau. The scheduling happens via Airflow. For training and model versioning, in this case, we have a special case, because we're using, as I mentioned prior, DeepAR. So out of our infrastructure, we are triggering SageMaker jobs for training and prediction, and use Amazon Simple Storage Service as free, as a place where to leave the data, so that the model can take them and use them for training or prediction. In terms of monitoring and alerting, for alerting, we use Slack and email notifications. We have different kinds of alert, either for failures at runtime, but also for training and prediction success, if it is processes that happen. Needs to happen on a specific in a specific time frame, but we also have data quality alerting. So we are verifying the quality of the input data. I can only recommend you to do this because from the model error for many products, you're not going to be able to understand if there are specific issues, and therefore the only way you have to be alerted if there were some issues at the pipeline upfront is by doing data quality monitoring as well. In terms of KPI and error monitoring, we have not only the quantified error of the model in production, but we have also 2 more models as a reference. One is simple moving average, and the other one is a prior model that we had that was in production, was used by our stakeholders previously. By comparing the errors, you are sure that you have a clear contribution of machine learning models, and therefore your business value is demonstrated. And moreover, you are even more sure that by comparing the current model with a previous version, you're even more sure that the model is working. It's very difficult to define a threshold, a clear error metric that informs if there are some issues with the model performances, because the model error of forecasting changes a lot over time. So, as I mentioned, I highly encourage you to use automatic monitoring and alerting, because also, if I didn't convince you with the other argumentation, it improves a lot transparency, reliability, and scalability of your processes. Thanks a lot for your attention. I am also sharing with you my LinkedIn profile. I hope you would like to add me, and also the careers that are currently available at Flaconi. Thank you.